In the past few videos, we have looked at the distance between 2 points, the equation of a line, the gradient of a line, and how we go about finding the midpoints. Now we're going to use this information to work with triangles on the Cartesian plane. To better explain how we do this, let's look at some examples. Consider the triangle ABC with vertices A with coordinates 1, 3, point B with coordinates 4, 1, and point C with coordinates 6, 4. Sketch triangle ABC on the Cartesian plane. Show that ABC is an isosceles triangle. Determine the coordinates of M, the midpoint of AC. Determine the gradient of AB. And show that D with coordinates 7, negative 1 lies on the line that goes through A and B. Let's start with part A. Sketch triangle ABC on the Cartesian plane. We've been given point A with coordinates 1, 3, B with coordinates 4, 1, and C with coordinates 6, 4. All 3 points have positive x and y coordinates. So all of these points lie in the first quadrant of the Cartesian plane. And we can draw in our x and y axes. Point A has the coordinates 1, 3. So it will lie over here. When plotting points, it is always a good idea to name the point with a letter and write down the coordinates. Point B has coordinates 4, 1, so it will sit over here. Point C has coordinates 6, 4, and this will sit up here. We can name the point as well. Now to draw our triangle, we simply join the points together like this. And now we can move on to part B. Show that ABC is an isosceles triangle. From our work in Euclidean geometry, we know that an isosceles triangle has 2 equal sides. So in order to show that this is an isosceles triangle, we need to show the length of 2 sides are the same. To find the length of a given side, we use the distance formula. Distance is equal to y2 minus y1 in a bracket squared plus x2 minus x1 in a bracket squared, all under the square root, where x1 and y1 are the coordinates of one point, and x2 and y2 are the coordinates of a second point. Let's find the length of AB. So let's say that A is our first point and B is our second. Now we can say the distance of AB is equal to the y coordinate of B, which is 1, minus the y coordinate of A, which is 3, in a bracket, squared, plus, open a second bracket, the x coordinate of B, which is 4, minus the x coordinate of A, which is 1, in a bracket, squared, all under a square root. Now we can simplify the values inside the brackets. 1 minus 3 gives us negative 2. We can say negative 2 in a bracket squared, plus 4 minus 1 is 3. So we can say 3 in a bracket squared, all under a square root. Now we can square the terms in the brackets. Negative 2 squared is 4, plus 3 squared, which is 9. Put this under a square root. 4 plus 9 gives us a value of 13 under a square root. Now we can leave our answer in surd form for now. So let's tidy this up and make note of the length of AB over here. Next, let's look at the length of AC. Let's say that A is our first point and C is our second. Now we can say the length of AC is equal to the y coordinate of C, which is 4, minus the y coordinate of A, 3, in a bracket, squared, plus the x coordinate of C, which is 6, put this in a bracket, minus the x-coordinate of A, which is 1. Close the bracket, squared, all under a square root. Now we can simplify the values in the bracket. 4 minus 3 gives us 1, and 1 squared is simply 1, plus 6 minus 1 is 5, so we can say 5 squared, all under a square root. Now we have 1 plus 5 squared, which is 25, under a square root. And finally, 1 plus 25 is 26. We put this under a root as well. Now, side AC does not have the same length as side AB. So now we need to find the length of the side BC in the hope that it has the same length as one of the existing sides. So let's make some space. We can make a note of the length of AC down here as well. Now to find BC, let's say that B is our first point and C is our second. So we can say the length of BC is equal to 4 minus 1 in a bracket squared plus 6 minus 4 in a bracket squared, all under a square root. 4 minus 1 gives us 3. Let's put this into a bracket squared, plus 6 minus 4 is 2. We can put 2 into a bracket squared, all under a square root. 3 squared gives us 9, plus 2 squared, which is 4, under a square root. And finally, 9 plus 4 gives us 13, under a square root. Side BC has a length of square root 13 units, but so does side AB. This shows us that AB and BC have the same length. So as our answer, we say triangle ABC is an isosceles triangle because AB is equal to BC, which is equal to 13 units.